In this video, we're going to continue with our discussion on implicit differentiation and actually do some examples using implicit differentiation after we first say what our method will be for solving these kinds of derivatives. So our first step on implicit differentiation will always be to differentiate both sides of the equation with respect to your independent variable x, treating the dependent variable, which in this case will be y, as a differentiable function of x. So we're assuming y is a function of x in the first place. Y is the dependent variable, x is the independent variable. And then first step is to differentiate both sides with respect to x. And then after that, you just solve for your y prime. So here we will do a first example, and that first example is find the slope of the circle x squared plus y squared is equal to 25 at 3, -4. Let's do this problem the old way first. Well, the old way is to solve for y first. So we could solve for y here. We did this in the last video, and this is y is equal to either plus or minus the square root of 25 minus x squared. But really, this isn't a function in here if we have the plus and the minus. This is two different functions. One for the positive here, one for the negative. Note that our y value is negative. So really we want y is equal to negative square root of 25 minus x squared. And this is our function here for y, our y function in terms of x. So what is the derivative y prime? Well, y prime is, well, notice first off, this is negative of 25 minus x squared to the positive 1/2 power. So this is negative, bring the 1/2 down, 25 minus x squared to the negative 1/2, all times the derivative of the inside using our chain rule. Derivative of the inside is times a negative 2x. And once we have done that, we can rearrange this. Negative 2 and negative 1/2 cancel, so this is just x all over the square root of 25 minus x squared, just to rewrite it in a nicer way. Then we want to know what the derivative is at the point 3, -4. So what is that? Well, this is y prime of 3 evaluated at 3. And so we just plug in 3 here. This is 3 over the square root of 25 minus quantity 3 squared. So this is 3 over, let's see, 25 minus 9 is 16. Square root of that is 4. So this is 3 over 4. So we get that the slope of the tangent line on the circle x squared plus y squared is equal to 25 at 3, -4 is 3/4. Okay. Well, let's use implicit differentiation now to solve this problem. Well, our equation is x squared plus y squared is equal to 25. We then need to derive both sides of this with respect to x. The left-hand side here is 2x plus, and now we need to apply the chain rule on the y squared, the derivative of y squared with respect to x. Our outer function is y squared. The derivative of that is 2y. Sorry, I was off the page. And then multiply by the derivative of the inside function. Well, the derivative of the inside function is y here, so the derivative of that is dy dx, or y prime, however you want to write that. And then this is equal to the derivative of 25 with respect to x. That is a constant, so the derivative of that is 0. All right, and now we need to solve for y prime, or dy dx. So dy dx is equal to negative 2x over 2y, which is negative x over y. And then, to find out what dy dx is, we could just plug in x and y. X was 3, y was negative 4, and so we get negative 3 over negative 4, in other words, 3 over 4. So again, we get 3/4. All right, so we see that we can get 3/4 both ways, and we've now seen our example of how to use implicit differentiation. In general, implicit differentiation may be faster. In this particular case, these were roughly the same length of time. But again, in general, for most of our problems, implicit differentiation will be faster. And in fact, implicit differentiation may be the only possible way to do it in some instances. So we'll end our video here, and I'll have another video with a couple more examples coming up next.